Introduce you. Tom. Okay. So this is our first collaborative design session. I'm actually generating the fabrication tree diagrams for a production run of the brick press, the Power Cube, with guest production run director Tom Griffing. So we're going to explore. First, we're going to go through the design, and then all of us here, there's like 6, 7 of us. We're going to draw up the actual fabrication diagram and master index and procedure and quality control checkpoints for the production run tomorrow. So we're expecting a 2-day production run on Sunday and Monday. So let's start this. So tell us, Tom, first about the design so we can go through that. So the way it's going to work is we'll go through the design, and the goal of this session is to kind of divvy up how we could collaboratively produce this design diagram for the production run tomorrow. So we use this time to look at what Tom has as far as the design itself, and come up with a fabrication diagram which allows us to allocate tasks to everybody in a production run. So we'll see how that works out. It's a social experiment for collaborative design. Tom, take it away.
All right. Well, this version of the Power Cube, we have a number of enhancements to it, and one of the big things is we use a mitered frame.
Yes. What is a Power Cube?
A Power Cube is an open source ecology hydraulic power unit. This is a unit that has an engine and a hydraulic pump, and it supplies hydraulic fluid power for other machines in the OSE lineup.
So you give it gasoline and maintain it lubricate it with oil, and then it puts out hydraulic flow at a certain pressure?
That's right. That's exactly what it does, and it's a key component in the OSE GVCS, the Global Village Construction Set. It is used to power other machines like the sawmill, like the hole punch, the CEB press, and then the life track. So it's a key component in the OSE lineup of machines.
And at least 30 other machines. Okay.
At least 30 others, right. So the Power Cube has evolved, and now we have a version that is using some enhancements. And what I was getting at earlier was most notably is it has a mitered frame on it, and the mitered frame gives us some additional structural support. It makes full use of the internal space, and it also is a real cube instead of a kind of a rectangular box that's not regular. So we also use 2 tanks on it. We have a hydraulic fluid reservoir and a gasoline tank, and they're both fabricated using the same kind of materials. So this gives us the benefit of that we can only have one piece of stock, and then because that piece of 6x12 tubing is not a very overly common one in the steel suppliers, and so it lets us make better use of that steel that we get. In addition, it also gives us around a 7-gallon capacity for both the hydraulic fluid and for the gasoline. So that gives us additional runtime for the Power Cube, and it also gives us additional fluid capacity.
So to clarify, one of those big tanks holds the hydraulic fluid, and the other big tank holds the gasoline.
Exactly. The one that I have colored in blue is hydraulic fluid. The one in red is gasoline. I made it red, so kind of to indicate caution. Better be careful with this stuff. Yes, sir.
How many more gallons of gas does this new version have versus the old?
The original Power Cube, I believe it held about 1.5 gallons, and so this one holds around 7. So that gives us several hours more longer run time between refueling. So also with this version of it, we're changing to a 28 horsepower engine. I think we actually ended up with a 27 horsepower, but we're targeting 28. And then we're also using standardizing on a 1-inch engine shaft. Hopefully we'll be able to get only 1-inch engine shafts in the future. The pump we're using right now, it's a little bit up for grabs. So we're using one that has a larger 3/4-inch 11-tooth spline shaft. And the spline shaft, I like it because it gives a little bit of play, and it's also a larger shaft than the smaller ones that we've been using in the past. There's been some trouble with the shaft hollowing out the shaft coupling in the past. We're also using a double roller chain coupling, and so this coupling allows a little bit of play, but yet transfers full power. So that gives us some additional reliability on the coupling.
talking about couplings, transmitting or converting rotary motion from one side to another side, right?
Yes.
And from the engine to the hydraulic pump, right?
Right, exactly.
Okay. So you put gasoline into the engine, you lubricate the engine with the also motor oil, and then when you turn on the engine's going to spin a little shaft, right? And then you convert the rotary motion of that spinning shaft through that coupling into another shaft at the bottom where the hydraulic pump is, right? And then when the hydraulic pump's shaft rotates, then it generates the hydraulic flow, right?
Exactly.
Okay.
The hydraulic pump we're using is what they call a fixed displacement pump, and we're using it. It's about 0.98 cubic inches per revolution of the hydraulic pump. And this version that we're using now, it's a little bit bigger pump, and it's a little heavier than the previous Prince pump that we were using before, but for whatever reason it appears to deliver more hydraulic fluid, and it seems to give more power. So that's very encouraging. I'm glad to see that. So tomorrow we're going to be fabricating this, and so we're breaking it up into several different tasks, and the tasks that we have are going to be able to do them in parallel, so that we have some people working on, say, the hydraulic tanks and the fuel tank, and then other people working on the frame, and other people working on the assembly for the engine to pump plates where they're going to mount. And so that's what we're going to go into some detail in just a few minutes.
Mm-hmm.
Any other questions about the Power Cube, the new version of it?
How many horsepower was the previous engine?
I think the original one was around...
Original was version 1 was 18 horse, 1 and 2 were 18, and then we went up to 27.
27. I've seen some that were 25 with some of those old Kohler engines, and then the latest one I've been getting is a 28 horsepower engine.
Mm-hmm.
It's a common form factor, that Briggs & Stratton type of engine, and we could even ramp it up. I think they have 31, 32 horsepower engines you can get. It would be a drop-in replacement for it.
Same size, about?
Mm-hmm. It's that same two-cylinder Vanguard Professional Series. Okay. So,
one question.
Yes, sir.
So, are there any changes to this version of the Power Cube that reduce the noise level relative to, say, previous versions?
Oh, good point. I'm glad you brought that up. The muffler changed, and we now have a commercial Briggs & Stratton muffler, and it was specifically designed for this engine. And so the old version of the Power Cube, it had two small mufflers, and they didn't dampen the noise very much. And so now we have a larger Briggs & Stratton muffler, and it for many reasons it gives a much quieter performance for the engine. Let's see, what else have we got that we can talk about?
Other than the tanks, the engine, and the hydraulic pump, there's also the fan, the radiator as well, right?
Right.
What's the function of the fan and the radiator?
Whenever you have or using hydraulic fluid power, you end up with some inefficiencies in the power transfer, and those inefficiency ends up accumulating as heat in the hydraulic oil. That's the way it gets rid of excess power, if you will. And so, as a result, the temperature of the oil tends to heat up. And so the cooler is a heat exchanger. The oil passes through before going through the filter and returning to the tank. And then the fan is on there to facilitate the air traveling through the cooler to make sure that it gets good cooling capacity. Because an oil cooler is basically a radiator, and it only dissipates heat when air is moving across the fan.
So to clarify, the fan blows air to move all the hot air away from the Power Cube, while the radiator is like a channel with all these like heat sinks for the hydraulic fluid to pass through and cool it down through the thermally conductive metal, and then that hot air the fan blows away, right?
Right.
That kind
Exactly.
So you want to just explain the whole thing to us?
He's getting there. Okay, there's another advantage that we've got, another benefit that we've got on this power cube is we centralize all the controls on a control panel. And we've got the hydraulic inputs and outputs, the throttle, and the key switch all clustered on a control panel. So this gives, in my view, it makes it more simple to understand its operation. We have many advancements for future versions. We have many ideas about things we can use to enhance it, but that'll be coming out in time. This one today, before we do the production run tomorrow, we're going to, I'm going to be working like a fiend trying to get the other changes that we just discussed as far as to make it more modular. So the tanks, the fuel tank and the hydraulic tank can be detached from an existing power cube. And then also the engine will be on a quick attach plate that we can more readily yank the engine. Part of the idea is that what we'd like to do with the power cube is have it to where the power cube can do more than just pump hydraulic fluid. We'd like to be able to couple up an electric generator or air blower or water pump or any other type
compressor.
of compressor.
Mm-hmm.
And any other type of machines that can use mechanical energy. Even, we've discussed this to some length, a direct mechanical transfer for an application, say like a car or say like a utility vehicle. That's one of the things I'm interested in working on, by the way, a utility vehicle.
Mm-hmm.
Let's see. I think we've covered most everything in here. It has a...
What's that white cylinder? You go back to the front view.
The front view, we have a cylinder over here.
Yeah.
And this is a oil filter. And it's very important because in the normal operation of a hydraulic system, you have components begin to wear and you get metal shavings and other particulate contaminations in the oil, so we need a filter to filter it out. Okay. I'd like to talk a little bit about the procedure tomorrow. We'll go to slideshow.
So the big point about the extra modularity is that things like the engine or the pumps have been failing. If you can disconnect them within a period of 5 minutes, that's basically our design goal, then you can talk about having a power cube that breaks be ready in operation in minutes after that. Because we have a number of power cubes, and we can switch parts between them. So that's quite useful.
It also would help a lot for repair. And say if for whatever reason we have a component failure, it'd be good to be able to change out an engine or hydraulic pump or a shaft coupling. And that's proven to be time-consuming and problematic in the past, so that it would help to have that modularity to be able to quickly pull it apart and fix things and put it back together. Eliminate downtime, that's always good. So we have several different tasks, and I've basically outlined the different steps of the procedure for building a power cube here. The first step is going to be to cut steel. So we have I've outlined the different steel members here that we're going to be cutting, and this is going to change a little bit based on the new frame discussions that we've had. So that's the first thing. Secondly, we're going to fabricate the tanks. Now this is going to be the two tanks. We have the hydraulic reservoir and also the fuel tank. And these are going to be using the 6-inch by 12-inch rectangular tubing. So we'll cut it off at 26 inches, weld a plate on either end, and weld accessory flanges or filler necks or different components on it as necessary. We also need to weld onto it the mounting hardware for mounting the engine plate, and because the engine will be suspended between the two tanks. The next, we also have the shaft coupling. And this is something that is going to be have to be fabricated just for this application, and so what we have is two pieces of the shaft, and the engine takes a 1-inch keyed shaft, and the hydraulic pump takes a 3/4 inch 11-tooth spline shaft, and so we have large shaft couplings for those. We're going to cut each of those in half and then connect the two by a double roller chain coupling, and that at any rate, I don't have it the drawings for it right here. We'll be getting more information about that before tomorrow, and but that's going to be a separate activity. Now, many of these tasks can all be done in parallel. Say, cutting the steel can be done. That's one thing. The shaft coupling is another. Fabricating the tanks is another thing also. So they can be done in parallel, so we can boost our production time. We're going to then weld the frame. So the frame is going to be welded as one unit before attaching anything to it. So this is going to be, anyway, a separate module by itself, the frame. Then the engine and pump mount. Now this is an assembly where we have a plate that bolts to the engine, and then it has a space where the coupling goes in between the engine and the pump, and then we have another plate where the pump mounts from the bottom. And then the plate is also going to have quick attach features, so we can have both vibration isolation from the tanks, so it doesn't transmit the vibration to the tanks, and then it'll also have quick attach bolts, so we can quickly unscrew those two bolts and then pull the entire pump engine assembly.
So just to clarify, one plate for the engine and the engine mounts from the top, and then one plate for the pump and then pump mounts from the bottom, right?
That's it. But these have to be all one integral assembly, and the supporting members between there. Basically, the engine plate has to support the pump plate, the pump plate and the pump assembly, because that's all going to dangle from below. And so the plates also, they need to be very parallel with each other, because if they're a little bit skewed, then you have the shafts, the two shafts will be off center, and you get additional friction, and it'll destroy the coupling a lot faster.
Tom, don't we want to have a third plate, which means that you can take the pump or engine off independently?
That's true. That's I've heard that in the designs, and I'm still wrapping my mind around that one. So that's coming along.
Okay. Yeah, because think about it. If you had a plate that stays there all the time, and on top of that is the engine plus its assembly, and on the bottom is the pump and its assembly, so you can take either off independently as you need to without having to take both at the same time. But we'll see if we can fit it into this production run. Mm-hmm.
Okay, next on the list is fabricate the control panel. Now this one, the control panel, it's going to sit between the two tanks, and it has two 1-inch brackets that attach to the tanks, and then the control panel bolts to those two panels. The control panel is going to have needs to be made out of 1/8 inch steel, and it's going to have holes for mounting the quick attach connectors for both the supply and return, and then also the tank return, the throttle control, and the key switch. I did make a note about that, is whoever's working on that, we need to pay special attention to the key switch, because it is a D-shaped type hole where it's flat on one side and mostly circular the rest of it. So that you need to make sure that's fabricated the right way, because if we just drill a round hole, then the key switch will rotate. It'll spin in the hole, so you can't turn the key. Wiring harness. I think that'll probably be, I'll be doing that, and we probably need some help documenting the wiring harness fabrication. That's something I've done a few times already, but it's a little tricky at best. I have several steps outlined here. Because we're using a mix of a wiring harness that was already developed, that I bought a commercial wiring harness that connects to the back side of the key switch, and then we're fabricating the rest of it ourselves, as far as going to the fan, to the battery, to the solenoid, and the other components in the power cube. The oil cooler and the fan, We basically have an oil cooler. It's like a radiator, and then this one we're going to basically put the fan on it, and then we're going to attach it. It came with some mounting hardware for it, and we're going to use that to mount to the fan. But yet we want to make sure that we don't. We use some vibration isolation in there to keep the mounting from damaging the fins on the oil cooler. And then we come to the big step, where we actually take the engine and the pump, and we install that into the frame assembly. After that, we install the oil cooler and the fan on the side of the frame assembly. And there's going to be on one side of the frame, there's some expanded steel. That should have been in one of the previous steps in fabricating the frame. And so the oil cooler itself will basically bolt to the expanded steel, and it has some rubber mounts on it that mounts rather easy. Then we install the control panel, and when we say install it, there's several different pieces that go to that. We position it there, and then we have to connect the hydraulic lines. And this is, at this point, we can tighten the hydraulic lines on both sides, both to the oil cooler and to the control panel. And these are JIC fittings, so we want it to be good and tight, but we need to be careful we don't over tighten it. As I understand, there's some problems with over tightening the JIC connectors. Then the wire harness and the battery. So we're going to drop the battery in its slot, and then connect up the wire harness to the various components. We're going to connect it to the fan, the solenoid, and the other components up here. And I don't have details on these screens, but we basically have the hydraulics. We're going to connect the suction plumbing. We're going to connect the supply plumbing, and then we're going to fill it with fluids. That includes engine oil and hydraulic oil, and then the gasoline. And then the next thing is we start testing. Any questions? Okay. Well, that's great.
So now let's talk about how we go about doing the fabrication diagram and how do we divvy up tasks.